Okay, there we go. Give it one of these two. Yeah, yeah, yeah. I'm here with Alex the Entrepreneur. What are we building? I think you said something about a testing platform. What do you got for us today?
Yeah, I got Recon, a new way to write and run invariant tests. This is a project I've been working on for over a year now with me and my co-founder, Antonio Vigiano. We met at DSS last year. And basically, what he created was called the Chimera framework, which is basically a specific solidity framework that allows you to write tests in Foundry. And then you can run other tools such as Echidna, Medusa, Control, and Halmos. And you can debug any broken property with Foundry. And so that's the key aspect is we're trying to get people to use other tools because they have they're just better at other stuff, such as fuzzing or even formal verification. And the way we make it work, I mean, under the hood, we got a lot of good stuff, which is fairly advanced. I'm actually going to show you the staging so I don't leak any customer data. We got a few customers now. We worked with Badger, Corn, Centrifuge, and more recently Credit Coop. But basically, the thing we built is a cloud platform to run invariant tests, which is a very advanced type of testing that most protocols that want to deploy on mainnet have to go through, ideally before audit. And then some people like me, they use them to actually find bugs in smart contracts. So you can see an example of a run here. I was actually fuzzing Morpho, and I don't have any bug for Morpho, so I'm not going to reveal anything crazy here. This is just some testing I was doing of ways in which I could, for example, lose value. And what happens is we basically can set up our tests on GitHub. So in this case, I have created my own org and my own repo called Simple Lender. And then I can just paste the URL here. So I'll just give you a real example of how I basically do it to find bugs in smart contracts. But basically, I've set up this private repo that I have. I will then basically just paste this URL. And because we're using the same framework, which is called Chimera, then our Cloud Runner is automatically compatible with any test that I write. So this is all the configuration I have to do. I just do this and I press a button.
But you
And
said
what I
that was
will
a
get
private
after,
repo. The service can't get to it, right? There must be some kind of GitHub access you have to allow to the site or something.
Yeah, this is an awesome question. Yeah, our pro version allows private repos. So all
Cool.
you have to do is go here and you basically install any repo
Got it.
via a GitHub app. So this is
Cool.
fully private for customers, and we basically can clone recursively. We also have a lot of advanced stuff that I can talk about later. And then I also want to show you a demo of how to actually do it so people can get started with this. And the key idea is that basically this is running the tool in the cloud. So I don't need to have multiple machines. I can just, quickly do it. And then the coolest thing is we have some nice stuff like the ability to rerun the job, download the corpus, and share. So I can literally press this button and then I can go in the chat. And now you, as possibly a white hat that doesn't necessarily need to have all the access to GitHub, etc., I can just give you access to this so you can see the repro and you can possibly triage it or possibly help us fix the bug if it's a important thing. But the key idea that we enable is that because we're using this specific framework, we're basically able to convert any broken test that is broken by another tool, it's broken by Echidna in this case, we're able to convert it to a Foundry test. So that's the key aspect is that
Really
perhaps
nice.
your CTO or your tech lead may understand how invariant testing works, and so they can set up the tool and run it. Whereas other engineers may be very effective at smart contract writing, but they may not be as good at using these tools. And
So you
so
can
you can
bring it
just set
back
this
into
up
your
once,
local.
and
Yeah,
it automatically works even as a
nice.
CI/CD. I can give you an example of a public repo. Is actually the liquidity governance. We worked with liquidity fairly recently. And so you can literally see in the repo, they stopped maintaining some of the tests I wrote. So these broken properties don't mean that there's a bug, But the way this looks is a little like this, where it shows you how long it took, it shows you what worked and what didn't. And then for each broken property, we automatically give you this Foundry repro so that even the liquidity team, which as far as I know, didn't write Echidna invariant tests in-house, they only use the Foundry ones, they can still debug these properties and check whether they're worth fixing or not.
Cool. So far, just to get my head around it, it's kind of like a SaaS product that does invariant testing and fuzzing on your code base, even if it's a private code base. And then once it finds some stuff, like whatever the magic happens behind the curtain in the cloud, you handle all the infrastructure. But then when it finds some stuff, then it can like re-implement those tests into your Foundry and basically put it back into your code base to have the tests that will check for the things that you happen to find kind of out on the edge. Is that a good way to put it so far?
Yeah, this is I mean it's magic when you use our templates because our templates are really well developed. And by the way, the easiest way to get started, I'm literally gonna show you like a random smart
Right.
contract. So
Yeah.
I'm just gonna type Etherscan. This is one of our previous customers, is Corn. They recently deployed this swap facility, but it's basically a random Etherscan contract. And the way we would write this type of invariant test for them is we will just copy the ABI, and then you can go to our website at getrecon.xyz
So
slash
anybody can
tools.
do this.
Yeah,
Neat.
exactly. Slash tools slash sandbox. And I'm just going to paste the ABI. And now I basically just give a name to the contract. In this case, I would call it perhaps the swap facility. So let's call it swap facility. And then I just toggle it. And it's basically automatically scaffolding me this template, which is compatible with a runner, which is compatible with Foundry, because this is all Foundry tests. And at the same time, these are compatible with Echidna and Medusa. And it makes it so that you basically get this magic functionality that anytime we can break any property with other tools, we're able to show you the repro with Foundry so that you can go back to what you know. And so on the day-to-day, I actually have these, first of all, I have a template for the people at home. It's called Create Chimera App. We have it at Recon Fuzz. And Create Chimera App is basically a Foundry project that already has a few of our boilerplate. I have already here, locally I called it Austin demo, just so that for the sake of time. But basically, we have this folder called Recon. I'm zooming in a bit so it's a bit easier to
I can
see.
see it
And
perfectly.
basically, we have a few files. Do you see them?
Yep.
Amazing. And so the key idea is that we need to abstract the constructor, and then we need to abstract a few more ideas. So in the setup file, we have a function called setup, and this will allow a developer to specify their constructor. And this constructor will be used by the critic to Foundry, which is basically the Foundry tester, with which you can debug with Foundry and run the invariant test with Foundry. And then it will also be run with the critic tester, which is the one that you can use for Medusa, Echidna, and even Halmos and Control. And so basically by using this simple idea, we're now compatible with all the tools. And then the other files that we have are called before after, which is for ghost variables, which is an advanced idea. Most of the times beginners don't need it, whereas people that are writing complex testers may need these ghost variables to track computation over time, basically balances over time, changes of balances, changes of value, or even operations. And then we have the properties file, which is used to write global properties that are going to be tested by these tools. And then lastly, we have kind of the meat of the tester, which is called the target functions. And this target function can take a really long time to write. And so the demo that I showed you before, where I was
You paste
scaffolding
the
these
ABI
tests,
in, right? Yep.
that's
This is where you
exactly what
get
we're
that.
doing. We're
Yep.
writing these target functions so that if I'm doing a quick and dirty coding experiment, I can literally just copy these and go
Nice.
back to my target functions and perhaps paste them. And now, even though it's clunky, we don't have like a nice tool that does it. At the end of the day, it gets the job done and it helps you get to coverage, which tends to be the reason why people don't use these tools is it takes too long to get to coverage. And
Hmm.
our goal at Recon is to help people get to coverage within 3 days, meaning that if you work for 3 days on these tests, your tests are actually trying every combination, which is actually not as easy as it sounds. So if I can show, going back to the previous demo, here on the global run, this is Morpho, for example. A run is basically comprised of a logs, which is basically the output from the terminal, from the tool. But you also have the coverage report, and that's because with invariant testing, the key question is which combinations are you testing? The tools work in a way in which they basically try to call every function you expose, which are exposed through the target functions. And then your goal is kind of to make it so that the tool tries all of the combinations so that it explores all of the possible states, or at least a high number of those states, so that it's able to break the properties. And this is where we have a really interesting debate between formal verification and fuzzing. Fuzzing tends to be kind of the pragmatic approach, whereas formal verification is the one that, once done right, leaves
Exhaustive.
no uncertainty about it. So we are taking more of the statistical approach because we think we can make it so that all of these setup can be fully automated, and so people can just quickly focus on the properties. Whereas if we can, once we see that the tools in formal verification evolve to a better point, to a higher quality, we will simply switch. And the key idea is that because you're using this framework, which abstracts that away, then hopefully one day, switching from Echidna Medusa and using Almos and control will be as easy as clicking this
Hmm.
button, which today doesn't yield those great results. But hopefully, once the tool evolve enough, that's all you're gonna have to do. Just click the button, let it run in the cloud, and in a few hours you get it formally verified instead of just invariant tested.
Really cool. So your target audience is Solidity developers, protocol engineers, product engineers that are writing Solidity, that are trying to work quickly to get to exhaustive tests that cover as much as possible statistically. And developers, if they want to get started, can go to getrecon.xyz. They can use some of your tools now. Uh, is there more of like a service angle where they get so far and then they want to come ask you questions and you kind of like team up with them? Like, what is that? Would I, as a Solidity developer, more likely just get in here and use your tools, or would I more likely kind of like hire you as a service to help me, or even just like maybe not even hire you, but get some feedback from you one on one? I don't know. It's not like you're going to work for free, but you know what I'm saying?
Yeah,
What is the best path, or what is the most likely path for a protocol
yeah,
engineer to interface with
yeah.
you?
Yeah, my suggestion is for all engineers to write invariant tests, and so that's why we built this. We used to have this Halo-free sad music where we show all the logos of protocols that got exploited, and that's why I started Recon, was because I really don't want to see those type of exploits happen again if I can prevent some. And so I believe that this tool can help with that, and so that's why I believe in this. And then on a more pragmatic side, I thought we could get away with just selling the subscription, but it turns out that it's actually really difficult to learn this type of writing, this type of test writing. And so most customers, they end up first working with us and doing what we called a invariant writing engagement, where we basically write the properties, set up the tests, and then once they go through that, they some of them choose to buy the subscription so that they can continue to maintain those tests. And what I really found is that second time founders all immediately
Come
get it
back.
and they start using the tech. Whereas
Great.
first time founders, they always do it too
They
late.
don't
They
know what they
always
don't
want
know.
you,
Yeah.
yeah, they just want you to find the bug. And then once you find the bug with this tool, then they're like, oh, give me the tool. But they never do it early. So my biggest advice for people starting out is to do this very early. I can literally give you a demo here of how we can prevent critical bugs in about 15 minutes. And the key idea is that if you do what we call invariant-driven development, where you just think about some key properties that your system must maintain at all times, and then you just test those all the time, you will be able, I'm not saying you're not going to have zero bugs. So this is not a substitute to auditing or to security contests and bug bounties. However, internally, you're going to be able to prevent a lot of mistakes that will be easily caught by running the tool for about 15 minutes to an hour. And so that's really the best point. And then there's people like me that I've done this for over a year now. And so when I'm doing a bug bounty, I will sometimes use the tool to also try and possibly raise an impact. So I'm trying to maximize an impact for a bug bounty. However, for most developers, the best usage is on the blue side, is in simply writing these few tests, having them run in parallel, and then anytime something goes wrong, you get an alert or you get a CI/CD message, and then you go fix those bugs.
That's really cool. Really nice. I like that there's like different stages here where you can tinker around with the tool. You don't necessarily have to engage you guys. You can try some things. But I think what you're saying is you don't know what you don't know. So you should engage us and we can show you through the ropes on the first pass. And then by the second pass that you'll just want to use the tool and the tool will make sense. Really cool.
Yeah, the biggest advice I have, and it's really underused, is to check our starters. They're on the same website on getrecon.xyz. But basically, we have starters, a generic starter. We have a starter for EigenLayer, one for the Renzo protocol that is built on top of EigenLayer. We have libraries and also properties that can be easily reused. I can go over this one that we built with Centrifuge and we more recently reused with Credit Coup. But the idea here is that this is literally one file. You just give us your ERC 7540 vault, which is an extension of the ERC 4626 vault. And then you literally just copy paste this test. You set it up the way I showed you with the Recon template. And now in about 15 minutes, you're able to find possibly some bugs with your implementation with close to zero effort. Then there are many other of this type of properties, and especially for landing protocols, these tend to be fairly simple to write, and then they can have a massive impact. So if you want, I can go through a very quick demo of I'm gonna write like the most basic landing protocol ever. And in doing that, we can show you how a couple of global invariants can prevent critical exploits just because you're checking for those all of the time.
I'm
Okay?
interested just to see the most simple lending protocol. Sounds great.
Amazing. So yeah, I got the repo, again, the create Chimera app template. It starts with this counter contract. So I'm just going to call it lender. And I guess the simplest contract we can do would have some sort of a deposit collateral with an amount. And most likely we would have some sort of function to borrow.
You're not
And
using
then,
Copilot. You're not using Cursor. You're just like
no, I'm
raw
raw
dogging some
dogging,
solidity.
it until until I have to. I built some small websites with AI, but all that code is completely unmaintainable. So I'm not a fan, but I'm looking at it every day. So I'm trying it
Good.
all the time, but I'm still not. It's not
I think
good enough for
that's
me.
good criticism. I've written some stuff with
Yeah.
AI that is weirdly verbose and strange. The code you're saying is hard to maintain. It gets the
Yeah.
job done,
So
but then when you need to come back and change things, you're like, what did it do? Yeah.
yeah.
Go ahead, keep going.
Yeah, that's really the key. And especially with smart contracts, you're supposed to write the least amount of code. And so we are definitely looking because ideally we would have AI improve these for you. So I'm not saying we're not
Right.
going to try it. It's just today, if I give it to Claude or I give it to Cursor, it eventually messes things up. And so
Hmm.
it's just not at that level. But the day it is, you're gonna have a new button on Recon where it's like scaffold with AI. I'm gonna be the first adopter. It's just it's really not there for me yet.
I hear you.
And so to make a long story short, we basically have we could simplify a lender to effectively having free key operations, the idea of depositing, the idea of borrowing, the idea of having a price. Obviously, we would have a collateral token, a debt token, and an oracle. So that will be a more appropriate way to setting this up. But just for the sake of demo, I'm going to just quickly hack this out. So we have only one lender, and we basically have an oracle. So what we
That
can do
calls
here is
set
just have
price, I'm guessing. Is the set price the Oracle function? Okay, cool.
yeah, exactly. So we're just gonna mix all of them together so we can have some sort of a deposits, a borrows, and then we would have some sort of a price, and we will make all of them public so we can grab them if necessary. And then we wouldn't have a lending protocol if we didn't have some sort of a liquidation logic. So I'll mention it, but I think we can get away with this. But the key invariant that I want to show is the invariant that broke Euler V1. So it's actually a $200 million critical bug that I'm about to explain in these simple terms. And it's this key idea that no user action should be able to cause a self-liquidation. And that's because a self-liquidation is not necessarily always bad, but anytime you can cause a self-liquidation for which the value that you got out is greater than the value that you put in, you basically stole money from the
You can
protocol
rug.
and you're
Yeah, okay.
basically causing a critical bug. And so all we have to do to introduce a critical bug here is that when we borrow, we're going to forget to put a CR check, which will be to check if we are collateralized. So effectively, we could actually, I guess I'll finish the function by adding the deposits. I'll set the price here to the price. And then I'm going to borrow by simply setting the borrows to be plus equal to the amount. And because I'm forgetting about the collateralization ratio check here, then what's going to happen is if I add another function to flag a liquidation, so it could be as simple as check liquidation, external. So we will define our collateral ratio as the ratio between the deposits time a precision factor over the borrows. And then we will need to multiply that by the price. So I'll just put the price here. And because we can assume that the price is going to be scaled, we can just divide this. And so we're basically saying that this plus this needs to be greater than this by a certain ratio. And so the last thing you will need here will be some sort of a collateralization ratio.
Ratio.
So which I'll just set to, let's say, 1.518. So we need 50% more value in the collateral. And so our check liquidation will basically return so it will be returns a Boolean, and it will basically return if the deposit over the borrows are less than the collateralization ratio. And so this is basically the key idea in many lending protocols. Obviously, we don't have interest, we don't have a market, we don't have a lot of things. Just like in our tester, we're not going to have a lot of stuff. But at the end of the day, the key idea is we're going to go to the setup, we rename the contracts to our lender, and we are able to quickly deposit, to quickly deploy it. We're going to go to the before after. The before after is going to have a simple check to say whether it was solvent. And then the check for solvency is going to come off of the function that I wrote, which is called check liquidation. So I'm just going to check on the lender if I'm liquidatable. And my assertion is going to be that I'm never liquidatable after a user operation. So now we can go to the property. The property is going to be, let's call it property. And it's going to be property check or property never self-liquidatable. And so all we're going to say is that we're going to assert, so we're going to say that if I am liquidatable after some operation, then I must also be liquidatable before, because I can never become liquidatable off of my own operation. And so what I'm going to say is if after dot
Unless you were like
is
changing the price. If you were the actual Oracle or something like that. Sorry to interrupt. You're right. You
exactly.
wouldn't be. Yeah, I got you.
Exactly, you got it. And that's why, well, once we go to the target functions, I'm going to have to do that hack where anytime we change the oracle, we don't track the liquidation because the oracle you have to assume. And this is also why pool oracles are super dangerous, because you're giving people the button to change the price. So I'm not a fan of those oracles. So this is actual alpha on finding bugs, but definitely be mindful of this. But that said, what we're saying is if we're not solvent after, then EQ, which is our equivalent assertion, we want to be not before dot is solvent. So must never turn insolvent by user action. And maybe I made a mistake, but if we do, we'll go over the check in a moment. So now
And you're
we
saying how
wrote
to
our
trigger this is we basically deposit an under collateralized amount, and then immediately we should get actually liquidated because it shouldn't have ever let us deposit an uncollateralized amount. Am I thinking of that in
exactly.
like caveman terms? Okay, good.
Yeah, you got it exactly. It's really that simple. If your protocols lets me get more than what I put in as a landing protocol, this is a critical bug and it will be 100% exploited. As far as I know today, there are bots that will immediately detect this and they will drain any protocol that has this type of bug. So this is a bug that can be difficult to find, because imagine if we had 100 different functions that can change the state. And this is why invariant testing can be really good, because it scales in that way. But at the same time, the property is very simple. It's a very elegant property because you specify it this way. The remaining part for us will be to simply, I'm going to have to delete these target functions. I'm going to compile with forge build. And then I'm going to have to sort out perhaps a couple of compilation errors. So let's see. This test file will delete, we don't need it. And then we're gonna remove this foundry assertion because we're gonna run Echidna. Now we're gonna just have to ensure that this needs to be true because you should, or rather, I think it's as simple as saying that these two are supposed to be the same. So we can just do this. So before is so if the after is insolvent, then before must also be, or rather, if the after is not solvent, then the before must also not be solvent. So they must be the same value. And so now we're gonna just get it to compile really quickly. I think I'm gonna just do this, which is our true assertion. This is basically the equivalent of logging an event which contains this string and then asserting that this is true. It's just a utility we have in the Chimera framework to quickly write this test. Now the tool compiled, so I can grab the ABI for the lender, and then I'm gonna paste this ABI back in our builder. So I'm gonna just
Okay, so
refresh.
far you haven't even had to commit your code. I was thinking we were going to have to commit our code and then give our repo over to but you're saying nah, just get the ABI and throw the ABI in here,
Yeah.
come back with what they
Everything.
answer and put it back into this is
Yes.
cool.
Yeah. Everything you can do in our platform, you can do through open source tool. We don't have any vendor lock-in. However, we think our technology is so much more convenient that is worth the price, but there is zero vendor locking. It's 100% based on open source. So what I'm going to show you anybody can do, you basically built the tool, or rather built the target functions. I'm going to grab them and I'm going to go to my target functions, which are empty, and I'm going to paste these functions. I then remember that this is a admin function, so we're not going to have the modifier here. Whereas here on the before after, I'm going to create this modifier with ghosts, which is basically just going to call before. It's then going to perform the operation and then call after, so that we now have a way to track the state of our system over time. And so now we can abstract all of that away by simply adding the ghost variable checks here. And even check liquidation could argue that we don't really need it, but I think it's fine to keep as is. But fundamentally, this admin function cannot have the ghost variables, because otherwise it will be cheating. You will just be able to, self-liquidate by moving the price. And now, because we're using the Chimera framework, I ran Forge build, which is Foundry, right? But because this test compiling Foundry and the template is shared between all of these tools, this means that when I run this command, echidna dot dash dash contract critic tester with this config. Now Echidna is going to be able to run, which is the invariant testing tool, the first invariant testing tool built by Trail of Bits. They actually are building a new one called Medusa. And now the fuzzer is running, and it's basically trying to break these properties. So I think we ran out of tests. So let me just do dash dash test dash limits to maybe 1,000,000. And also I'll just use a format text so that it shows. I guess I'll just keep as is because
The
the
format's
terminal
cool,
looks
man. It looks cool. Yeah.
it looks cool because it's
Yeah.
inspired by AFL, I think, American fuzzer. It's the most popular fuzzer. But basically, our tool is now trying to break these properties. And the fact that it's not broken means that maybe either I have a misunderstanding or perhaps there's something off. But fundamentally, this is what the workflow will
What's
look
the
like.
price
We're
set
running
at?
the
Do we
tool.
need to set the price function at all?
We have the way to set the price, so we should be able. And now I'll actually show you why I guess why we didn't use Foundry, to be quite honest, for our work is really because these tools give you the coverage report by default because the coverage report is a key tool that helps you figure out how good your tests are. So now that the tool is done, it's going to save this coverage in the Echidna folder. So if I go to Echidna covered.html, I can just reveal it in the Explorer and grab it. And now I can find my target functions. Target functions.solve. And let's see. So at this point, it seems like if you see, we have basically a green line here and a red line here, right? So
Hmm.
what does this mean? This means that this line was hit. Most likely there's something wrong with my ghost
Mm.
variable
It
check,
never
which we'll
got
have to
to the
debug.
lender stuff. Okay.
Yeah, maybe that's my mistake. And basically, this red line indicates that this was never covered. Sometimes there are bugs because of how Solidity mappings end up having issues when you use the optimizer. However, in this case, I'm pretty confident I made a mistake. So this goes back to the workflow, which we check the coverage report. But now instead of just blindly fixing something that I don't understand, I'm going to go to the critic to Foundry and I'm gonna just try my tester here with a 123 value, and I'm just gonna run this test as forge test dash dash match test test critic. And so because our handlers are shared between Foundry and Echidna, once I figure this out on Foundry, it's gonna work on Echidna. So as you can see, there's a division by 0 that is causing the revert because I didn't think about the edge case. So we actually trying to introduce a bug, we actually introduced a new one, which is if borrows is 0,
Okay.
we have to
It's not the
return
price that was missing, it was the borrows that was missing. You have to create
exactly.
some initial borrow. Okay.
Exactly. And so in this case, you're not liquidatable if the borrowers are 0 by definition. And so this is a interesting invariant in many lending protocols where the idea is that you should be able to repay when you have 0, or rather you should be able to always withdraw when you have 0 borrowing. And by introducing this exceptional logic for the borrow equals 0, now this is possible. And most likely we also fix the bug that I introduced. And you can see that now it compiles and it runs. So now when I go back to Echidna, Echidna will be able to explore more states and possibly it's going to be able to finally break this property. Obviously, what I showed you is kind of a micro version of the workflow. It tends to take quite a long time on complex code bases, but this is fundamentally what we have to do. We run the tool, and then the tool is basically able to break these properties, provided that we give it enough time and enough handlers to make it so they can explore the interesting state. We actually have had a recent event. It was in December. It was called FuzzFest. It's also at getrecon.xyz. We have basically a 4-hour video about the event. It's been held with me, Dashian or Deshan from Cypherin, and then Jocelyn and Benjamin from Trail of Bits, as well as Daniel from Origin Protocol. And it's basically 4 hours of talking about how to get started and more advanced stuff. The last talk by Benjamin is about the Uniswap V4 tester. So it's a super complicated, super advanced talk, whereas Deshan and Daniel do a talk for beginners on why and how to fuzz and how to find these type of bugs. And that could be a great next watch for people at home to get more familiar with this type of idea. And instead, we basically have this idea of shrinking the sequence, which is the idea that the tool found a way to break the property, and now it's trying to reduce the
Kind of rolling
number of steps that
backwards.
it takes
Okay.
to reproduce it. Exactly.
So that
So it's
failed
really
means
easy.
it did catch it and it knows about it. But right now, what it's trying to do is like optimize the test to make it fail quicker
Exactly.
or something like that.
Exactly.
Find
The
the
least
problem.
amount of steps so that it's easy for you as a human
When you
being
go to
and not as
copy
a
it into your
machine to understand.
foundry, it's cleaned up. Cool. That's really nice.
Exactly. And so, yeah, as I stop it with Control C, we get the logs here. And now I'm going to show you basically the secret behind our technology is that you can obviously understand this and kind of, massage the code yourself, but we do this every day. So we have a tool at, this one is at tools/echidna, where you basically just paste the logs and it
Nice.
gives you the Foundry
Nice.
repro. And so that's how our product really works. We just have a really opinionated setup, and now we're able to automatically scrape all this stuff for you. And so now we can go to the critic to Foundry, which I use to debug here. But now I'm going to use it to actually reproduce the exploit so that as a triager or as a blue team developer on the blue side, you're basically able to figure out that the bug is there. And now perhaps via dash dash decode dash internal, I can figure out that there is no check for liquidation. And so most likely something went wrong in my tester. And I basically was, I didn't allow myself to, effectively, although it's funny how in this case, it kind of, the sequence is kind of a bit scammy. Like you see, it's borrowing first and then it's checking here. So I'm pretty sure if we simply do this, we should have it. However, this is another bug that I wrote because in this case it's even safe. But that the reason why this doesn't fail, it's another bug in itself because I have a borrow, I have no assets, and I basically was able to break it because of we still have the division by zero. So it's interesting how in rushing that's a key way to introduce bugs. But at the same time, in terms of just, I guess, of if I want to show the bug, it would probably look something like this, maybe, where you will fundamentally be able to, or maybe I will just overborrow by a ton. But basically, I guess so. I'm not going to be able to reparate the fuzzer gods are not happy with the sloppy code I shipped. So it is what it is. But basically, that's kind of the idea is that in reasoning at this high level, you can write just a few properties. You can go through them. And obviously, in 10 minutes, once I'm in a different headspace, I'm probably going to be able to write a better property. But that's kind of the workflow that you go through. And in doing that, you basically make your contracts a lot safer because now, even though there's a lot of things that can go wrong in the contract, you now have safeguards around what the contract can do. And anytime the contract goes over those safeguards, you are immediately warned because you have that sort of a box that these type of tests give you.
And everything you did here was separate from reaching out to you guys. Basically, anyone can do this asynchronously for free using your tools and other tools that exist in the space. What you provide is, first of all, these tools as a public good, but then kind of like a service layer for those first time founders for when they don't know what they don't know, and you can help them through this stuff. Is that right?
Yeah, we basically can do, we have the CI/CD, which is a subscription. And then if founders need more help, we can write the invariants. And also I can personally do security reviews. Some people call them audit, but it's basically a security review done by me. And that's what we do. And currently it's all built on open source technology, such as Medusa, Echidna, Foundry, Almos, and Control. And most of these, I mean, this has underlying as GAF. This one uses HEVM. This one uses REVM. And then Almos and Control, they have their own EVM. which is the symbolic variant. But all of these tools are open source. So, and the same goes for our template. So people can get started completely for free. And our goal is to make it so that everybody uses this technology. And then if I can show you kind of a glimpse into the future of what we're doing ourselves, of what is possible, and why, I guess we can command a fee for a subscription is that we basically have the more advanced automations. So we have a thing called dynamic replacement. I think I have a demo for this. And what dynamic replacement does is we are able to replace variables in a contract. So let's say we were to set up some
Like
sort
the
of a
price or
precision
something.
here. Yeah,
Okay.
something like a precision variable of 118, which is really common because let's say you have a vault or you have a precision in the pricing. And so people tend to do this. And the limitation we currently have is we only replace it on the setup file. But as long as you write your variable in this way, we can then grab the variable, set the type, and then let's say you're trying it for USDC. So you want only
10 to the
six.
8. Yeah, or 6 or whatever. Yeah.
Exactly. We're able to replace them, and basically we can rerun a testing suite by changing these variables so that you don't have to manage them on GitHub. And then this actually becomes pretty advanced when you blend it with fork testing, because Echidna and Foundry, they allow to fork a chain. So you can literally provide any RPC. You literally give us your RPC, and then you click this button, which is the dynamic block replacement. And what we're able to do is if you set up your tester as a uh, fork test, which means that you have VM.warp and VM.roll, then what we can do with our tester is we can grab your RPC that you provide us here. We can
It has
query
to be
the latest
public,
block
right? I mean,
via.
there's no local host RPC here. Like, there's a little caveat here that needs to be like a public RPC that you have running.
Yes, yes.
Okay.
This will be any public RPC. Could be, Alchemy is really good, really convenient. But even for exotic chains, you can just pass, the CRTO, bear chain testnet, whatever you have, and then we can query the latest. And then our tool can automatically replace these blocks. So that means that if you're using the invariant test as a monitoring solution, you don't have to change them on GitHub every 30 minutes or something like that. We can just change them and rerun the test for you. And the culmination of this is what we called governance fuzzing, which we are rolling out to our current customers. And it basically allows us to listen to on-chain events and then automatically apply all of this dynamic replacement. In this case, this demo is for the Euler EVK. So it's the Euler vaults. But anytime an Euler vault on Sepoly is deployed, we can listen to these events and then rerun the tests, the test from a suite that we wrote, so that we know that each new deployment doesn't have any form of misconfiguration. And so this is kind of what we're trying to do, is that because of the level of skill and the effort that it takes for you to write these tests, then they're also some of the most valuable tests. And so what we're doing with our own tooling is we help you reuse those tests in production so that you never reintroduce a bug, which is how many projects get exploited, is because they stop testing, at the last mile instead of just, rerunning the test. And so we made it so that, you click a couple of buttons, we spin up a listener for the events on chain, and that we can rerun this test so that founders, that spent that money to write those invariant tests then get to benefit from having those invariant tests run before any meaningful operation. And because of how invariant test works, we are able to apply them before any governance operation happens, so that you can literally preview what would happen instead of having to find out in production.
You don't want to find out in production.
You
Awesome.
never want to
Great.
find
This is
out.
a really
Yeah.
great demo and presentation, Alex. Alex the Entrepreneur. So they can go to getrecon.xyz to start tinkering with your tools now, and just be on the lookout for new stuff that you guys are putting out also. And if you need that service, they can come talk to you one-on-one too.
Absolutely. Thank you for having me. And you can also find us on Twitter. Just search for Get Recon, and we're going to be the first result.
Awesome. Thanks, man. Thanks for showing off.